Good afternoon. Good afternoon, ladies and gentlemen. I would like to say thank you for coming in this video conference. I'm sorry. Wait. Yes, like this. Okay, I would like to say thank you for coming in this video conference. Great to see you all. Let me introduce myself. My name is Ikhwan Taufik. You can call me with my second name. It is Taufik. I am from 3D printing teams, especially from Universitas Gajah M Yogyakarta. In this opportunity, I would like to talk about fuse deposition modeling or FDM. Before I start it, let's pray together to open this meeting of this day with Basmalah. Bismillahirrahmanirrahim. Okay, thank you very much. Yeah. Before I start it, I give you illustrations about the basic of machining process. In manufacturing, we can classify the fabrication process into three groups. There are subtractive, formative, and additive manufacturing. Okay, let's talk about subtractive manufacturing. Yeah, look at the picture. Subtractive manufacturing is a one-off manufacturing process by removing part of the dimensions of the workpiece. For example, if you have the workpiece with the dimensions approximately 50 multiple 50 millimeters, and you will make something like a nut or bolt, of course you have reduced your workpiece until your nut or bolt already done. The example of subtractive manufacturing are turning, drilling, and milling. And the second one, formative manufacturing. Formative manufacturing is a manufacturing process with the principle of forming workpieces. In this kind, we must have a mold to make something. The example of formative manufacturing is the casting process or molding process. You can see in the picture more clearly like this. Yeah. And the second one is additive manufacturing. Of course, the example of this one is 3D printing. Yeah, because additive manufacturing is a manufacturing process with the principle of adding material. Yeah, we add material little by little until the shape we want is finished. Yeah, the example of additive manufacturing is 3D printing, and 3D printing is included in the additive manufacturing group because in the process there are additional material. Okay, next slide. I will talk about the other name of 3D printing. If we talk about 3D printing technology, we also need to know the other names of this technology. There are many names of 3D printing technology, like additive manufacturing, like rapid prototyping, solid freeform fabrications, automated manufacturing, and maybe layer manufacturing. Yeah. In the simple statement, we call it as additive manufacturing, because there are additional materials in this process, like my statement in the front. We add material little by little until the shapes we want is done. Furthermore, we can also call 3D printing technology with rapid prototyping. This term is the first time popular at the beginning of the emergence of 3D printing. In fact, we can easily and cheaply make prototype object using 3D printing technology. The same name, we can call it with solid freeform fabrications because this process like adding deposition material one by one on the next layer until the shape was done. The name is computer automated manufacturing. This is because 3D printing technology works automatically using computer devices that are integrated in the system. Therefore, the 3D printing process is also called computer automated manufacturing. Okay, the last but not least, we can call this technology with layer manufacturing. We named layer manufacturing because there is a process of adding material layer by layer above the previous layer. Yeah, you know lah. Okay, we are going to the next slide. Yeah, the next slide. What is that? Yeah, in this slide, there are some model of 3D printing, and you can see in the video like this. Okay, please enjoy this video. This video talking about the model of 3D printing. Yeah, this is the SCARA, Cartesians, and the yeah, this one is Delta. The model is Delta. This is the product of 3D printing. There are many products of 3D printing. We can make everything with 3D printing machines. Like this. This is the lithopen technology. I'm sorry. I think the sound is not good. I don't know why. Yeah, this video made here. Okay, next slide. In this slide, we will see the standard nomenclature of 3D printing technology. This international standard has been developed by ISO BC261 and ISTM F42 in close cooperations. On the basis of a partnership agreement. between ISO and ISTM International with the aim to create a common set of ISO STM standards on additive manufacturing. Actually, there are many 3D printing techniques in the world, and we can classify into 7 types based on ISO or ISTM. First is binder jetting. Yeah, this is the binder jetting technology. Second one is direct energy deposition. Next is material extrusions, include fuse deposition modeling or FDM, fuse filament fabrication, and contour crafting. Next, material jetting. And the second one is powder bed fusion, include selective laser sintering and direct metal laser sintering. And the next is sheet lamination. And the second one is fat photopolymerizations, include SLA or stereolithography and digital light processing or DLP, and continuous liquid interface production clip. Yeah. Okay. All of them are popular method of the 3D printing process. This is the most popular method of 3D printing process, that is a fuse deposition modeling or FDM. However, this is a trade name registered by Stratize, the company that originally developed. Okay, yeah, fuse deposition modeling or FDM. Fuse deposition modeling or FDM was developed by Scott Cram in the late 1980s. It works on an additive principle by laying down material in layers. A plastic filament is undown from a nozzle to produce a part. This picture is the simple illustration. Yeah. Simple illustration about the fuse deposition model. You can see there are build material spool, or we can call it filament material. The filament material is inserted into the extruder, or what is that? Extrusion head. Yeah, and the material is also heated to above the melting point, and the model is produced by extruding a stream of material that forms layer and returns to hard immediately. Yeah. Okay. After the first layer is formed, the platform moves down. Yeah, this platform. You can see this platform. Or the extruder moves up. Then the extruder returns to work to build the next layer. Yeah, like this. Yeah, but yeah, this is just the simple illustration about the fuse deposition modeling. Okay, next slide. Yeah, the process works by melting plastic filament that is deposited via a heated extruder layer at a time onto a building platform according to the 3D data supplied to the printer. Each layer hardens as it is deposited and bond to the previous layer, like this. You can see the picture. This is the filament and extruder, and the print part. This is the platform we move down, or the extruder move up. Okay, next slide. Yeah. So how it works? Okay, in these slides, I would like to talk to you about how to fuse deposition modeling works. At least there are three important steps. Yeah, the first steps is pre-processing, and in this process, uh, drawing and slicing process or sectioning get design into layers. And these steps we can start by drawing an object. Yeah, we can draw using many kind applications like Inventor, SolidWorks, SketchUp, Blender, and the others. Even if we cannot draw using the computer applications, we can use a 3D scanner. However, we must make sure to save the file in the STL format or OBJ format. Yeah. After that, we can slice your CAD design with application like Cura, Simplify, Slicer, Repetier, and the other similar applications. I think this step is very crucial because we have yeah to setting many parameters to get the best printing result. After we found the parameters, we can prepare the file to slice and save in the G-code format. Okay, the next step is printing process. In this step, we can see that the product is built layer by layer. You can see in the video after this slide. I think, yeah, the last post processing. In these steps, we can take our product and remove the support disposable support material. We also can finishing our product with the other step like painting with the other color or sublimate with the chemical liquid or the other. Okay, let's see the next slide. Yeah, this slide is the process the tile, and you can see in this video. Okay. Okay, I'm sorry. Yeah, we can see once again to discuss this video. You can see this process. I will. I'm sorry. I will stop it. Yeah, this in this video. This is I think this is the first step. Yeah, you can slicing your CAD design. Uh, this is the representative, and after that, you can yeah you can see this video show you about the extruder. Yeah, like this. Yeah, this is the support material, or uh, we call this is the filament. Yeah, this is the drive wheel, and this is the nozzle. Yeah, nozzle, and uh, you can see the part will layer by the first layer, second layer, and the next layer until the products was finished. Okay. Yeah, the finished part. After uh, the printing process is finished, uh, the next process is post processing. Yeah, you can remove the support material like this, and after that, you can uh, supplement with the chemical liquid. Yeah, or other. Yeah, like this. Okay, ladies and gentlemen, the next slide. I have one more video. This one is how to print with my 3D printing machines. This kind of 3D printing machine, of course, is fuse modeling, yeah, or FDM. You can see this video. Uh, you can plug the stop contact. Yeah, this file. You can prepare. And after that, you can choose the file to print. For example, yeah, kotak to this one, yeah, to multiple egg. The process is heating until temperature is finished, and this process, yeah, this is the process printing of fuse deposition modeling. This is the real machine, yeah, not what is that? No, this is video is real video and take with my machine, my 3D printing machines. Yeah. This is the product of the printing process. Just cube, not cube. I'm sorry. Yeah, just the shapes with the size 2 equal to and height 18. Like, okay, I think that's all. But there are of FDM techniques. Yeah, you can now. Uh, First, the FDM printing technology is very flexible and it is can handle with the small effort tanks on the lower layers. And I think the FDM generally has some restrictions and cannot produce undercuts without support material. But many materials are available, yeah, such as ABS and PLA, among many others, with trade-offs between strength and temperature properties like that. Yeah. And yeah, my slide is finished. I think that's all. Thank you very much for your great attentions. And if any questions, yeah, this is the time for you. Okay. Okay, ladies and gentlemen, please. Yeah. Check.